And good afternoon, everybody. And glad to see you here. It's a great meetup, and with all the different network and developers, right? And so AT&T, we are operating the different networks. So I think that's a great opportunity and to share with everybody what the industry is moving in terms of the open source networking area, and how the developer community will be able to help and support the whole industry moving forward, and for not only the comprehensive orchestration platform, but also how we can rapidly grow the healthy ecosystem with all the network, the operators and the developers and in the world. So today, I will talk about something called the orchestrating MV workloads in the multiple clouds. And basically, that's one of the major missions about the ONAP projects. So for those who may not be familiar with ONAP, so ONAP stands for the Open Network Automation Platform. So it's one of the open source projects hosted by the Linux Foundation Network Fund. So Linux Foundation itself is open source, hosting a lot of the open source projects, and it has its own domain for the open source networking part. And so it has umbrella the project called Open Source Networking Fund, which basically hosts about 6 networking related projects. And the scope is also expanding, and the Tungsten, the fabric is also applying to be part of the Linux Foundation Networking Fund. And so within this fund, and there are currently there are 6 major projects, right? ONAP, OPMV, FDIO, ODL, and a couple of other projects. So ONAP is one of the projects in the networking fund. ONAP provides a comprehensive platform and for the automation orchestration about the network functions, right, that will enable the service providers to be able to rapidly deploy and orchestrate and automate the new services, new network services, and also support the complete lifecycle management. And in addition to that, ONAP is also an ecosystem, and it's open source like a family with all the different service providers and vendors from all around the world. And so far, there are more than 100 members of the Linux Foundation Fund, and most of them are very active in the ONAP. And there are 27 platinum members, and 9 of them are service providers, 3 in North America, 3 in Asia, and 3 in the Middle East and Europe. And so ONAP was basically established in the first quarter of last year, and so far it's only like a little more than 1 year old. And so we had about 2 releases in the past year. So the first release called Amsterdam release, and basically to verify and prove that we will be able to deliver what we promised to deliver, and for the ONAP in terms of its orchestration platform. So we delivered the Amsterdam release in November last year. And we just delivered second release. It's called Beijing release about 2 weeks ago, and focus on the S3P, meaning the scalability and security and the performance. And so that's the Beijing release architecture. And so in the overall ONAP architecture, so basically there are 2 types of the environments. One is called the design time environment, and the other one is called the runtime environment. And the design time environment basically enable the business operators, right, and service providers to be able to design, define, and program the platform. And by defining the different services, onboarding, uploading different VNF and artifacts, and to be able to, for the runtime environment, to be able to execute those business logics as programmed and defined in the design environment. And so the other part is the runtime environment, basically execution, right? Execute whatever has been designed, been defined, and using the business process to be able to automatically deploy and orchestrate the workloads and different VNFs into the different clouds. So in the design environment, for example, you will have the resource onboarding. So basically you onboard different resources and different VNFs and validate those resources so that resource will be able to be seen by the operator and in the catalog. And you can design the service, you can design different type of products, and you can create the policies. And the policy framework that will be able to support the users to define the operational policies, and to define what are the rules, policy rules, what are events, trigger, what are actions, etc. And it will also provide a tool, it's called CLAP, the closed the control loop automation management platform, and we'll be able to, for the service providers to be able to design the control loop functions, right? And using the policy and using the orchestration, all the different tools to have the control loop and also hook up with the DCAE, the data collection, analytics, and event platform. And it also has the change management, because we need to consider the upgrade and configuration change upgrade for the VNF itself. And we have the design, the testing, and the VF, the VNF verification program to basically verify the compliance and the verification about the different VNFs and with the platform itself. And everything will be stored in the catalog, and the catalog will be shared with the runtime environment. And in the runtime environment, you'll be able to use the variety of the different components, tools to launch the service. For example, in the runtime environment, you will have the dashboard, which also for the orchestration, administration, and all the management functions, which is Portal, and it's implemented using the VID, the virtual infrastructure deployment, and provide a template. The template will be able to automate. For example, calling the service orchestrator, orchestrate the platform, they deploy the different infrastructure and set up the different tenants and authorize and authenticate and authorize the tenants and VNF, and then the whole how it can be using the closed loop functions and to be able to manage the whole life cycle of the VNF and services. And you can see in the runtime environment, right, there are basically lots of basic components to support those functions, and although it can be automated using VID templates. And first is policy framework, which basically is managing different policies. You can create, delete, and enable different policies for the different controllable functions, and also for the used by the optimization of homing services. You have DCAE. DCAE stands for the data collection, analytics, and events. It's basically a set of the services, and it has a set of the DCAE collectors. We deployed it to the infrastructure, to the host, from the host, right, and to the VM, to the VM, to the VNF, and to the service to get the collect different metrics. And that metrics will go through the homes, which basically is called correlation engine, and to find the root cause of any, for example, any fault that has happened, and it correlate and find the root cause and the trigger using the policy to trigger necessary functions. And you have a service orchestration, which basically to orchestrate based on the need from the users, right? To orchestrate different VNF and VNF components and to deploy and with the different clouds. We have the runtime, the NAI, called the available and active inventory. So basically, it's the runtime database, and to have the current service status and current infrastructure status, and other information, static information about the platform itself, as well as the VNFs and the services that's running in the different clouds. And we'll have the SDNC, the SDN controller, which basically controls level 0 to up to level 3 networks. And we'll have the application controller, which basically controls layer 4 to layer 7, the virtual network functions for the lifecycle management, and including, for example, restart and stop and migrate, etc. And we'll have another called virtual function controller, and which better do the similar things, but in a different way. So the reason is, so ONAP was the merge of two prior the open source project. One is called OpenO, the other one is called OpenEComp. And the VFC was carried over from the OpenO side, and AppC and SDNC carried from the OpenEComp side. And so in the first release, we're proving the concept, so all the functions are put together. And for second release, we put them together as well in order to improve the platform, the stability, and to improve the S3P, the performance. But for the Casablanca, for the next release, and we're working on the maybe a consistent unified architecture, right? And to have a unified generic VM controller instead of having two the application controllers, which may duplicate some functions large. So that will be the planning and work for the Casablanca, the C release, and we're in the planning stage for that. And there is a multi-cloud, the component, which basically will is a mediation layer. And basically, for example, it gets the standard API call from northbound saying, okay, I want to deploy this VNF, and with this specific the MIM requirement, and then the multi-cloud broker will be able to find the necessary plugins for the backend clouds and translate those standard API calls and to the cloud-specific functions. And for example, it may translate into the Kubernetes that APIs using the home charts, or using the, for example, Azure's ARM templates, or some other different mechanisms to work with the specific clouds that has its own specific syntax and the requirements. And underneath is infrastructure, which basically infrastructure itself.
Yeah, I have a few questions here. So one is, you have the SDN controller over there, right, in the ONAP architecture. Now, in the OpenStack, also you have a controller. So how do they talk to each other, or then you don't deploy an SDN controller? How does that work?
So in the OpenStack, so SDN controller implements the neutron function. For example, neutron provides the virtual network setup, the standard northbound commands. And of course, neutron has its own implementation to establish those different networks using the OVS, OVSDB. But on the other hand, ODL type of the SDN controller can also implement the plugins for the neutron, and in order to establish those the network flows and on behalf of the OpenStack. And so here the SDNC here is basically it's for the for today, for the standard release and 15 release, is for the SDN WAN type of the connections. So that's across the domains for the different clouds. And for example, could be programmed the gateway between two different data centers, and for those type of functions.
Okay. Another question I have is on the DCAE, the network analytics, right? So does it use the existing collectee, etc., the open source, what is already, some of those projects?
Yeah, so DCA itself, and for the reporting format, we're using the VES, the VNF event stream. So it defines the data model to report the metrics in a standard format, so that it can be consumed by the other northbound components of the ONAP. And for the collecting itself, for example, the collectee is used by some collectors. And but in the some other collectors may use some different collecting the method. But the more important here is that you're using the collections, and will report the metrics back using a standard VES format, so that whatever metrics being collected will be understood by the northbound components.
Thank you.
Yeah, thank you for the great question. Yeah, any other question? Yeah. So in the southbound, it's basically a bunch of the infrastructure side. Yeah.
Yeah. Quick question. I'm not seeing any abstraction for security mechanisms here. Do you have anything for security?
Can you please?
Yeah. Go to one of the.
Yeah. Hi. I'm wondering if there's any plugins or any abstractions here in any of these layers for security. I'm not seeing that clearly from this picture.
Yeah, so there is a component called AF, the Application Authorization Framework. So basically, it takes care of the cross-components application level authentications, and it takes care of, for example, the storing the different secrets, and provides that the client plugin the library, so that different components will be able to use in the plugin and work with AF for these authorization services and for the security purposes, including the tenant authentication. Yeah.
A question: and how do you take into account service chaining within deployment, for the deployment, and also after the deployment?
Service chaining itself will be considered as a high-level service. And first, we need to define the service chaining itself, how the chain is composed, and what other VNFs are composed in the service chaining. And then, so from the orchestration perspective, it gets a service initiation request, and saying you have a service chaining which compose of, let's say you have a virtual firewall, the VNF, you will have the load balancing VNF, and you will have the proxy VNF in this service chaining service. And then the SDN service orchestration will be getting the service initiation request from the users. And then the SSO will decompose the service chaining the service into 3 different VNFs, right? A virtual firewall, load balancer, and virtual proxy. And after that, and each VNF could be also decomposed into the different VDUs, virtual deployment unit. Sometimes we call it VF component. And then, so the service orchestrator will work with the OOF, the optimization function, and then to decide which is the best site to deploy the virtual balancer, which another different site to deploy the virtual firewall, and which is the third best site for deploying the virtual proxy, the VNF. And then it will also, when we decompose that, we also define the networks and also the network flows that between those different components, right? And then service orchestrator will, after it knows which specific the best size to deploy those different VNFs, it will call the multi-VN component, and different plugins will be able to deploy the VNFs onto different clouds. And then we will go call to the SDNC and to create those networks between those different VNF components. So the network flow we created so that the traffic, the initial traffic will go into the VNF. Let's say in this case, let's say it's a virtual firewall, and then after virtual firewall, the outbound virtual firewall will go to inbound of the virtual load balancer, and the virtual load balancer outbound of the virtual load balancer will be going to the third, the virtual proxy. Okay, so the diagram I just introduced is Beijing release architecture. So we also discussed the key architecture, long-term architecture principles, and for the ONAP to be as a kind of target to evolve the architecture, because for each release, the architecture have some kind of variations. Major components will be there, but new components may be coming up. For example, for the Casablanca release, and some proposal may be using the Istio instead of the microservice bus, right? And so to manage different containers. So that will be kind of a more like a implementation, but it has to be conformed to the principles that everybody, at the beginning of the ONAP, everybody agrees, and from the architecture perspective. So the key architecture principles include modular, including the microservice, and include module-driven. And so from a modular perspective, right, and so basically all the different components needs to be implemented or architected in a modular way, so that we will have the APIs and for the better consistent behavior between different components, and easy for the scaling different components, and for the portability. And so all those APIs are standardized and documented using Swagger, and also we aligned with other industry standards, and whenever it's available and it's appropriate, and reuse, so that we don't have to reinvent any wheels, and from the standards compliance perspective. And we adopt the microservice-based paradigm, so that we will be able to run the different components as a standard microservice, and all the interface will be based on RESTful APIs, right? And that's because in the ONAP, there are implementations are using the different type of languages. For example, the primary language is Java, and most of the components are implemented in Java, but some components are implemented in Python, and a few components are also implemented in, let's say, Perl, in the Go, for the container, and some other different languages. But using the microservice, and so all those implementation details will be hidden, and for the different components, right? And so from scalability, from the economic perspective, it's more viable from long-term perspective. And we are using the ONAP Operations Manager for onboarding, for instantiation, and the different components, and for the scalability perspective. And so each component as a microservice needs to register for now with the microservice bus. And for example, just general questions, right? We have different multi-VN plugins, and each plugin is different microservice. Some plugins are written in Python. The Kubernetes plugin will be written in Go language, and each plugin will be able to register with the microservice bus, so that whenever Northbound needs to deploy the VNF or close in this backend cloud, it can find these plugins and discover these plugins, and to be able to use the plugins deployed. And so we also have to summarize the best practice for using the microservices. For example, separate data from the component using common key value store, etc., etc. And we are also using the model-driven paradigm and philosophy in order to align with information model, data model, and from the modeling subcommittee and from the external SDOs, for example, the HC and MV, they define the set of the different specifications, right, for the infrastructure modeling and for the data modeling components. And for example, even for the communication and for the consistency between different components within the ONAP, and the data modeling is also essential for each component to understand each other, just like for the data collection for the DCAE. You need to collect the different metrics, and each metrics needs to be put into the standard model, right? Standard data model, which conform to the VS data format, so that it can be understood by the other components. So model-driven is really kind of the essential to the success for the interoperability between different components. And we are also enable the integration with other systems through the MSVM proxy. So external system will be able to also register itself to be discovered by the components, and registers the RESTful API endpoints, and also registers versions, etc., so that it can be used by any of the components through a discovery mechanism in the MSV. Yeah, so here is the workflow for deploying the VNF into the different clouds and different sites. And so first you need to have a design time, right? You need to design the service, define the policy, define the onboarding the different VNFs so that the VNF can be verified and validated and put into a catalog. And the catalog will be shared with the runtime environment. And then the user can also define the service and products using different VNFs. And the example just mentioned, using the virtual firewall, load balancer, and the proxy. And then in the runtime, and for example, the service orchestrator get the request as the first step, saying instantiate the service SFC function, which includes the load balancer, proxy, and firewall VNF. And the service orchestrator then decomposes service into the, if there's a sub, we call it the child NSD, network service descriptor. In this simple example, it's only the VNF, right? But if it's the NSD itself, it's a nested hierarchical architecture. So the first step is to decompose the NSD into child NSD until it reaches the VNF level, right? And then it decomposes this child NSD into the different type of VNF, like a virtual firewall, virtual load balancer, virtual proxy. And then decompose virtual firewall, for example, those VNF into the virtual deployment unit. Sometimes there is no subcomponents. Each VNF itself is deployable. So itself is a VDU, the virtual deployment unit. But sometimes it has the multiple VDU itself. Okay. So after decompositions, and the service orchestrator then needs to work with OOF, the ONAP optimization framework, to decide what's the best site to deploy those different VNFs for this service function chaining. And OOF using the set of the service requirement, and also considering the current status about the usage about different VNF and infrastructure capacity by getting the information from NAI, the available and active inventory. And also there is a consult policy, right? And so say, okay, what's the current policy? For example, using this VNF. Let's say such one VNF may need the extra hardware capacity, like HPA capabilities, right? So for HPA capability, there's policy saying, okay, if you need the let's say CPU pinning and new memory, you have to go to the cloud A. Right, so this type of policy needs to be also be enforced through the OF, and through the executions, the OF, the optimization itself will find the best the cloud. Let's say cloud 1 for the virtual firewall, cloud 2 for the load balancer, cloud 3 for the proxy, right? And of course, you don't have to be different cloud. Maybe it's all the three best for all three VNFs in the same cloud. And after that, they give the information to service orchestrator. And service orchestrator itself will be able to work. Sometimes you need to work with the Cloudify, because the Cloudify has its own plugin and will be able to directly work with different clouds and with a more efficient way. But in some cases, right, and you be able to work with multi-beam plugins, right, and to as a cloud broker, and to find the necessary plugins like Azure plugin, Kubernetes plugin, and to deploy the virtual firewall on, let's say, on Kubernetes, and deploy the load balancer on Azure, and deploy the proxy on the OpenStack. So all this flows, and so all the major components work together and to finish the deployment of the functions. So basically, the important here is a service component plus a placement requirement. So let me go to the last slides. And okay, so this slide is basically the text about what I'm just talking about. Yeah, so the flows 1, 2, 3, 4, decomposing, and get the optimization, get different flavors, and put the VNF into the clouds. And so that's the last slide. So homing, so a little bit about the homing, we just talk optimization, right? And so it's called homing. Homing is a policy-driven placement optimization service that can allows ONAP to deploy the services automatically across the multi-site and multiple clouds. And so it's taking into account those different constraints. For example, the capacity requirement and available capacity of the different clouds, and what's the locations, what's the affinity, anti-affinity requirement, and what are the latencies that are required by the service, what are the latencies can be supported, what are the platform capabilities like the SRIOV type of DPDK type of the capability, and HPF capability, etc., and some other service-specific constraints depending on the different service. And so we call it the service components plus placement requirements, which results in the optimal resources and to be optimized. And then you can find the best site and to place this VNF. Not only that the site will fit VNF, but also by considering predicting what are the future workloads needs to be reserved or need to be taken care of, and by reserving a certain amount of the memories for the future, for example, the capacity for the future, right? And as I mentioned, the service requirement including latency, including the bandwidth, including the distance, proximity, affinity, regulatory requirements, security, etc., etc. And the optimization objectives may include latency, right, and less than 30 milliseconds. Like distance, you have to within like 200 miles. The cost, right, and when you deploy to this cloud, it will be operating cost like $100 a day, but in another cloud will be $80 a day, etc. And load balancing, right? You have to balance and from the disaster recovery perspective, not only the load and balancing, but also the recovering from the from disaster, etc. And when the OF is deciding those factors, right, it also needs to query the AF and ANAI, sorry, and to get the most recent information about the correct deployment status to get the best site. Okay, and I also list the link, and for if you have more interest, you can just go through the website. So that's the Beijing release documentation, and which is quite complete. So that's all for my presentation. Thank you very much, and I think we're just on time. Thank you.